Okay, so right triangle trig centers around understanding what the sine is, the cosine, and the tangent. So hopefully by now we got it down. The sine is the opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over the adjacent. We should have also added to our knowledge the reciprocal ratios. The sine is 1 over the cosecant, or the cosecant 1 over the sine. The cosine is 1 over the secant, or the secant is 1 over the cosine. And the tangent is 1 over the cotangent, or the cotangent is 1 over the tangent. Also in that, don't forget, the sine of 10 degrees equals the cosine of 80 degrees. The secant of 20 degrees equals the cosecant of 70 degrees. Tangent of 50, I won't do 15. Tangent of 50 degrees equals the cotangent of 40 degrees. All right, so we had all that. And then we had two types of buttons on our calculators. Right? The sine, cosine, tangent button will tell you the ratio, opposite over hypotenuse, etc., but they'll divide it out and they'll give it to you in decimal form when you give the angle. So you get a 20-degree angle. You want to know the opposite over the hypotenuse. Punch in sine 20 degrees, and it'll tell you that in decimal form. And ratios, when we give them in decimal form, we give them to how many places? 4 places, right? Then the -1 button is going to give you the angle. You're going to input the ratio either as a fraction or as a decimal. Hit your -1 button, and your calculator will tell you the angle. So that's what we've done so far. We added 30, 60, 90, 45, 45, 90-degree angles. Now we need to take trig out of the concept of just that and put it into a Cartesian plane or a coordinate plane with x and y values and all that. All right, so first thing we got to talk about is standard position. Standard position. So that's the first thing there. You can write that in, standard position. Standard position. All right, an angle is in standard position when the initial ray, so this red ray here is an initial ray, I-N-I-T-I-A-L, the initial ray, is along the positive x-axis. The vertex to the angle is at the origin, and it is. And I'm going to take green here, and I'm going to make a terminal ray. And that terminal ray can go wherever. I'm going to stick it like right there. Terminal ray. And again, I'm just going to label it here. Terminal, T-E-R-M-I-N-A-L. So you have an initial ray, and you have a terminal ray. And we have an angle now, right? Made up of the two rays with the common endpoint. Definition of angle, geometry. And there's two ways we can look at this angle. See, in geometry, we tend to stop at a straight angle, right? So, you know, you're opening up an angle, and we're 10 and 20 and 30, and we get to 90, and you're going past 100 and 120, and you get to 180, and you stop, and you say, that's it, 180, because if it goes like this, you just go the opposite direction. Well, in trig and in the coordinate plane, we just keep going. So go ahead and take your, let's do it in blue. So we're going to just draw an arc mark where the angle goes. We're going to start at the initial ray, and we're going to come over to this terminal ray. That's the angle. It's bigger than 180. Oh, it looks like I drew it at about 225 degrees. Because all the way over to 180 is 180, and then I went half of the other 90, right? Which would be 45. 45 and 180 is 225. So it's about a 225 degree angle. So A here, positive angles open counterclockwise. They open counterclockwise. So you guys remember way back to pre-algebra when I said, hey, why are the quadrants numbered the way they are? And I said it's because an angle in standard form. Because angles between 0 and 90 are in quad 1. But when they get bigger than 90, 95, 100, 110, 120, etc., they're in quad 2. But when they get bigger than 180, 190, 200, etc., now they're in quad 3. When they get bigger than 270, 280, 290, 330, now they're in quad 4, right? And that's why the quads go that way, because our angles open counterclockwise, right? Counterclockwise. However, we can have a negative angle. And negative angles open clockwise. So it's just math, so we are able to go clockwise. So what would be the value of this angle if we look at its negative coterminal angle? There's that word again. We used it yesterday. Coterminal. Coterminal means you have the same terminal side, terminal ray. So instead of going counterclockwise, what happens if you open clockwise? Now our angle is negative, and this one would be negative how many degrees? Okay, good. I heard a lot of 135s, and that's correct. A negative 135 degree angle is exactly the same as a positive 225 degree angle. They are one and the same. Same thing. Positive 225, negative 135, they're the same angle. And look, here's the thing with trig. Trig is periodic. So that 225 degree angle, let's go counterclockwise, normal way. Get to that 225 degree angle, great. What if I swing around another 360 degrees from there? So what if I go a total of, let's see if the brain will work, 585 degrees? What will the angle be? Exactly the same. A 585 degree angle, all the trig ratios are exactly the same as a 225 degree angle, which are exactly the same as a negative 135 degree angle, which I can spin around another negative 360, which is exactly the same as a negative 495 degree angle. And my brain can't keep adding 360s. It's just not easy enough. But you can go around 100 times. A negative 1,350 degree angle. Does that make sense? I don't know, I'm not even going to do that. It may not make sense. All right. You got to keep adding 360s. That one wasn't true, so I'll leave that. Luke, question?
So if we get like in the book where it gives us an angle that's greater than 360 degrees, we just subtract 360.
Yes, so let's say they said to you, we have this angle and it's 490 degrees. All right, don't do this in your notes because you'll just make things muddy. But a 490 degree angle, here I'll do it over here. Initial ray, 90, 180, 270, 360. What did I say? 400 and what? 360, 450. Why did I go 490? And 40 more. 490 degree angle. And you need to keep, which is exactly the same as a 130 degree angle. Which is exactly the same as a negative 230 degree angle. Which is exactly the same as and you can add 360s and negative 360s. All right. I don't want to get too far afield and blow your mind, but they keep going round and round and round she goes. Where she stops, only trig students know. All right. Next. So when we try to do all these similar triangles, all these trig ratios, it comes into play with what's called a reference triangle. All right? So a reference triangle is the right triangle that you form with the terminal side, and it's always got to be the x-axis. A reference triangle is a triangle formed with the terminal side and the x-axis. Terminal side and the x-axis. All right, so we have a 130-degree angle. And it doesn't matter where you go along the terminal side. I usually go toward the end because it makes a bigger triangle. Drop a perpendicular dot line down to the x-axis. You have now made a right triangle. And if it's 130 degrees to the terminal side, how many degrees are left to go from the terminal side down to the x-axis? Right? And hopefully you think that there are 50 degrees left, right? Because all the way is 180. We've gone, so here I'll do it in this color. We've gone 130. If all the way to here is 180, then that must have been 50, right? 180 minus the 130. Now that's really important because that comes up all the time, that kind of thinking of how much is left. So our reference angle is 50 degrees. So if you don't have your calculator out yet, make sure you get your calculator out right now. And I got to make some analogies to you. So our reference triangle is right there. Reference triangles were really big 30 years ago when calculators were like this big. Well, actually, it's been a little bit more than 30 years. 50 years ago, not too many people had a calculator, and we had tables. And all the angles for all the trig functions had to be in a table. And you didn't have a table that had a 7,835 degree angle. You had to know the reference angle that goes with it. Well, we have calculators now a little bit easier, but the concepts come up again later in other areas. So don't simply rely on your calculator, learn the concept. So for example, take your calculator, punch in 50 degrees or sine in 50 degrees, depending on the syntax of your calculator. So we're trying to find the opposite over the hypotenuse for a 50 degree angle. We're going to get it in decimal form. And your calculator says point what? 766. All right, 7.766, good enough. That's all we need to know. All right, now take 130 degrees and punch in the sine. So sine 130 or 130 sine, however your calculator does it. Did you get the same value? Ooh, remarkable, remarkable. And of course we should, because they correspond. The reference angle corresponds to the actual angle, the 130 degree angle. However, there is one other aspect that you need to take into place, and that is the SIGN. So, let me just try to get your thinking going here. We just, for instance, used the sine of 50 degrees, right? And let's think about the sine. The sine is the opposite, correct? What is the sign of the opposite side, positive or negative? Is that dotted line of the triangle, that value, positive or negative? It's positive because, again, what is it? It's really this value on the y-axis, right? The opposite? Okay. And it's over the hypotenuse, which is a radius of a circle. And can a radius be negative? Because you have a black hole, right? All right. We created a black hole, we would all be gone, and so would the whole world. So, positive divided by a positive is a positive, and guess what? The sine of a 50 degree angle is going to be exactly the same as the sine of a 130 degree angle. But let's do the cosine. Punch in the cosine of 50 degrees. What do you got? All right, point what? 1/6? Okay. Whatever. You got the number in your head, right? Now punch in 130 in the cosine. It's negative, isn't it? Same numerical value, but negative, right? Why is that? Because what is the cosine? What side over what side? Look at the adjacent side. Isn't the adjacent side of this reference triangle negative? Guess what? The sine is positive in quadrant 2, and the cosine is negative in quadrant 2. Now again, your calculator tells you these things these days. You used to have to do all this stuff with a table before. What would the tangent be in quad 2? Positive or negative? Think about what the tangent is. What over what? It's opposite over adjacent, right? The opposite in quad 2 is what? Positive or negative? Every opposite in quad 2 is always positive. Every adjacent in quad 2 is always, and so a positive divided by a negative is a, and the tangent is negative in quad 2. Let's go back to quad 1. If you make any triangle in quad 1, the opposite is always positive and the adjacent is always positive. Radius, again, always positive. So the sine in quad 1 is positive, the cosine in quad 1 is positive, and the tangent in quad 1 is positive. And I'm positive of that. Because all three are positive. Opposite's positive, adjacent's positive, hypotenuse is positive. So therefore, every trig function has to be positive. What happens in the other quadrants? Let's do the next two angles, and then we'll come back and finish this out, okay? So if you look at B here, so here we have a 320 degree reference, or 320 degree angle. Therefore, the reference angle will be how many degrees? Well, remember, that triangle has got to go to the x-axis. Do not go to the y-axis. Reference triangles always go to the x-axis, never to the y, always to the x. And therefore, our reference angle is how many degrees? And hopefully you said 40. Because we went around 320. And our reference angle takes us all the way back to 360. 360 minus 320 is 40. All right, take your sine, take a calculator, do the sine of 40 degrees. Again, however you need to punch it in. Sine of 40. What do you got? Point whatever, right? All right, do now 320, hit your sine button. And this time it is negative, isn't it? Ah, see, the sine is negative in quad 4. Sine is negative in quad 4. Same ratio. Opposite hasn't changed. The hypotenuse hasn't changed, but it's negative. What would the cosine be in quad 4? Is the adjacent positive or negative in quad 4? This is the adjacent right here. Is that a positive? Is that on the positive x-axis or negative x? Positive x, right? So that's positive. So the cosine, the adjacent's positive, the radius is positive, cosine is positive. And what's the tangent going to be? Tangent opposite is negative over the adjacent, which is positive. Tangent is negative in quad 4. Let's look at the last example. So remember, angles can go positive or negative. So where would you draw the terminal side of a negative 125 degree angle? Where would you draw the terminal side of a negative 125 degree angle? So now remember, you're going clockwise. You're starting here and you're heading this way, right? So hopefully you think, well, I get to here, I've gone 90. I need to go how many more? 35 more, so maybe about like that is negative 125 degrees. Now draw the reference triangle and figure out the reference angle. Draw the reference triangle and figure out the reference angle. Draw your reference triangle. Figure out your reference angle. And I hope you put your triangle right there. Remember, the triangle always goes to the x-axis. Your reference angle, we used up 125 of the 180, so what's left, 55? And these are always, reference angles are always positive, even though the initial, whoops, that's a 55, even though the initial angle is negative. Reference angle is a 55-degree angle. Hey, why don't you punch in tangent 55 degrees? You see the number? Now punch in tangent negative 125 degrees. Same value, right? Because guess what? The tangent is what in quad 3? Tangent is positive in quad 3. Why? Because a negative divided by a negative is a positive, right? Opposite's negative, adjacent's negative. What would the cosine be in quad 3? The adjacent is negative and the hypotenuse is positive, so cosine is negative. And what is the sine? The opposite is negative and the hypotenuse, so that's negative. So if you sum it all up, the sine is positive in quad 1 and 2, negative in 3 and 4. The cosine is positive in quad 1 and 4, negative in 2 and 3. The tangent is positive in quad 1 and 3, negative in 2 and 4. But you don't have to memorize that. You can just simply figure it out because you know opposite, adjacent, hypotenuse, radius, and whether they're positive or negative. All right, so this is the start of everything. Let's continue on. Trig in a Cartesian plane. So, and this is trig ratios in a Cartesian plane. All right, this is really amazing, but this is really simple. Don't make this hard because it's really, really simple. So we have an angle in quad 1. The terminal side is there, and we're going to drop down a reference triangle, and I'm just going to use just going to do it in blue. Just going to drop down and make a reference triangle. Okay. Now we have a certain angle. Now before I go too far, if you notice the point has an x-coordinate that equals whatever the x value is, right? Any point in a Cartesian plane. And would you agree I'd be looking at the value right there, how far it went on the x? So would you agree that this side is the value of x? Okay. And the y corresponds to this value, right? Right here. So therefore, this has a value of y, which is the same as there, y. Are you okay with that? So, let's go over to the left, and we already know that the sine is the opposite. I'm going to do that in green, divided by the hypotenuse in blue, right? We know that. Sine is opposite over hypotenuse. But for this triangle, what's the value of the opposite? Y. And what's the value of the hypotenuse? R. And guess what? Whether you're in quad 1, 2, 3, or 4, the sine of theta is y divided by r. It's a different way of thinking of the sine. But it corresponds exactly to the opposite over the hypotenuse. Exactly. That's where we got the y from, because y is the opposite. Where do we get the r from? Because the r is the hypotenuse. But it's another way of thinking about it. So if we have the coordinates x, y, we know that the y-coordinate, listen now, this is the key, the y-coordinate's the value of the opposite. The y-coordinate is the value of the opposite. And the x-coordinate is the value of the adjacent. So we do the cosine. We know the cosine is the adjacent over the hypotenuse. And again, the value of the adjacent is the value of x. Value of the hypotenuse is the value of r. So the cosine is x over r. And we can finish off with the tangent. Green O for opposite over a red A for adjacent. And guess what? The tangent is y divided by x. So where are we going with this? Well, we're going toward the next example. Meaning, if we know the coordinates of any terminal point, we can figure out all the trig ratios for that triangle. That's where we're heading. Now, you might say, but wait a minute. We need the radius. I know that the x goes with the adjacent side. And I know that the y goes with the opposite side. And let me just come back here and make this clear. I'm going to put an OPP with the x, and I'm going to put, whoa, that's backwards. An ADJ with the x. I can just change my colors. Brother. All right. The adjacent side is the x. The opposite side is always the y. So how do you get the radius? Pythagorean theorem. And that's what's right here, right? R is just the hypotenuse. How do you get it? The square root of the sum of the other two sides. So if we have the coordinates of a terminal point, we can get x, y. We have x and y, and we can get r. And therefore, we can do any trig function. All right, so let's see if we can apply that. And that's going to have to sink in a little bit. So now we get a problem like this. Find sine z, cosine z, and tangent z if the coordinates of the terminal point are negative 3, 4. All right. So two different ways of thinking. Remember, this is the x-coordinate, right? The negative 3, I'm right here, which is also the adjacent side. And the negative 4 is the y-coordinate, which is also the opposite side. So again, what we're trying to do is get you to the point where now, not only when you think sine, not only do you think opposite over adjacent, you also think y over r. So now we're just ready to say, oh, no problem. The value of y is 4. So how in the world are we going to get r? Well, we got to do the Pythagorean theorem. So let's come down here and do the Pythagorean theorem. So we got to do negative 3 squared. That's a 9. By the way, you should know the answer already because I picked it on purpose. Because guess what? This is a 3, 4, 5 triangle, right? You get the square root of 25. All right. Which equals 5, and our radius is 5. And guess what? The sine of z is 4/5. Okay. So all I did was the opposite over the adjacent, the y over the r. Tell me now, what is the measure of the reference angle? Z prime. What's the measure of this reference angle? Figure it out. You already know how to do it. Tell me what measure that angle is. And it almost looks that too, so which it should. Got it? How many have the measure of that angle? Let me see your hands. Okay, so remember, if you know the ratio, can't you get the angle? This was back day 2, maybe. What button on your calculator gives you the angle when you know the ratio? You should be saying to yourself, sine to the negative 1 equals 4 divided by 5, right? So what's the sine to the negative 1 of 4/5? And the answer is 53.1 degrees. That's our angle. Ha! Figured that out too, because of the trig ratio. Now we got to do all the other trig ratios, and we got to do a whole lot more. And the period's already over, but you know what? We got too much going on, so I hate to say it. I'll be finishing this by video. I'll be posting it, and then your homework is still your homework. It is what it is, but I got to quit there. All right. Better to go slow, though, and do that than go fast and not understand.